Hello everyone. Today I am going to explain some questions of our week 6 assignment. So let's begin. So first question is, what are the assumptions of linear regression? So basically linear regression has several assumptions. Like first is linearity, means there is a linear relationship between the independent variables and the dependent variables, and there is also independence. Like here the observations are independent of each other, and here also is homoscedasticity. So here the variance of the errors is constant across all levels of the independent variables, and here also is normality. Here the errors follow a normal distribution, and we have five number, no multicollinearity. So here is no multicollinearity, means the independent variables are highly not correlated with each other, and we also have here no endogeneity, which means the independent variables are not influenced by the errors. And here in this linear regression we also don't have outliers, means there are no extreme values that significantly affect the regression result, and we also have no perfect multicollinearity. This means there is no exact linear relationship among the independent variables. And our second question is, explain how decision tree algorithm works, what is pruning and decision tree, and what are its types. So basically decision tree algorithm works in several steps. Like first it start at the root. So here the algorithm begins at the root node, which represents the entire data set. And second, the feature selection happens, in which generally it selects the best feature that can effectively split the data into subsets. Here the goal is to find the feature that maximizes the information gain or Gini impurity reduction. And the third step includes splitting the data set. Means here the data is divided into subset based on the selected feature, and each subset represents a branch or child node of the tree. And our fourth step is repeat recursively. So here steps 2 and 3 are applied recursively on each subset until a stopping criteria is met. And this criteria can be a maximum depth of the tree, a minimum number of samples in a leaf node, or other conditions. And in the fifth step, we will use leaf nodes and prediction. So once the recursive splitting process is complete, the final nodes of the tree are called leaf nodes, and each leaf node represent a prediction or a class level. And in case of pruning in decision tree, basically pruning is a technique used to prevent overfitting and reduce complexity in decision trees, and it involves removing unnecessary nodes from the tree structure. And there are two common types of pruning. First is pre-pruning, and this type of pruning stops the tree from expanding further based on certain conditions before the splitting process. And common tree pruning conditions include a maximum depth limit, a minimum number of samples required to split a node, or a threshold for impurity reduction. And the second type of pruning is post pruning. And in generally in post pruning, it starts with a fully grown decision tree and then removes or collapse nodes based on the impact on performance using a validation set. And nodes that do not significantly improve the tree's predictive accuracy are pruned, reducing the complexity of the tree. And both pre-pruning and post-pruning are used to create simpler and more generalized decision trees that avoid overfitting to the training data. And we have a third question. What is random forest algorithm, and how does random forest reduce overfitting? So basically, the random forest algorithm is a powerful machine learning technique that uses an ensemble of decision trees for prediction. And here is how it reduces overfitting. So first, it will ensemble learning. Random forest creates multiple decision trees, each trained on a different subset of the data. By combining the prediction of these trees, it reduces the impact of individual noisy or biased trees. And second, random feature selection. So at each split in a decision tree, random forest consider only a random subset of features. This prevents any single feature from dominating the tree decisions and helps to generalize better. And in third step, it's like voting mechanism. So when making predictions, random forest combines the outputs of all the trees through voting or averaging. This collective decision making reduces the impact of individual errors and lead to more accurate predictions. So basically, by employing these techniques, random forest effectively combats overfitting, resulting in more robust and reliable models. So basically our fourth question is, what is the difference between precision and recall? Explain with example. So basically, precision and recall are two evaluation metrics used in binary classification task. So here's a simple explanation among with the formula. So precision is the proportion of correctly predicted positive instances out of all instances predicted as positive. It is calculated using the formula precision equal to true positives by true positives plus false positives. So if you take an example of this, so basically in an spam email classifier, if out of 100 emails predicted as a spam, so 90 are actually spam. So that is true positive. Means if it is spam, and if it signifies spam, then it is true positive, and 10 are false positive. The precision will be 90%, like 90 divided by 90 plus 10. So 90 by 100, basically it would be 90%, right? So, and what is recall? Recall is the proportion of correctly predicted positive instances out of all actual positive instances. It is calculated using the formula recall equal to true positives divided by true positives plus false negative. So the example of this will be in a disease detection system. If there are 100 actual positive cases and the model correctly identifies 80 of them true positives but misses 20 false negatives, so the recall would be 80%. Means 80 divided by 80, that is true positive, and plus 20, that is false negative. So the recall would be 80%. So in summary, precision focuses on the accuracy of positive predictions relative to all positive predictions, while recall focuses on the accuracy of positive predictions relative to all positive instances. And our fifth question is, what is K-means? How do you find optimal value of K-means algorithm? So K-means is a popular clustering algorithm used to group similar data together. It aims to minimize the variance within cluster by assigning data points to the nearest centroid. Here is how you can find the optimal value of K. So we can find using ALGO method, run K-means with various values of K and plot the sum of square distance SSE for each K. SSE measures the total distance between data points and their cluster centroids. Look for the elbow point in the plot, where the direction in SSE starts to diminish significantly. And second is Sylhouette's coefficient. Here we will calculate the Sylhouette coefficient for different values of K. It measures the compactness of clusters and the separation between clusters. Choose the value of K that maximizes the Sylhouette coefficient. And our third step is domain knowledge. Consider prior knowledge about the data or problem domain. If you have insights suggesting a specific number of clusters, use that as the value of K. So by combining these approaches, we can determine the optimum value of K in K-means for our specific data set and clustering requirements. So what is confusion matrix? Sixth question. So in confusion matrix is a table that is used to evaluate the performance of a classification model. It is a useful tool for understanding how well a model is able to distinguish between different classes. So the confusion matrix is made up of 4 cells: true positive, TP. These are the instances that were correctly classified as positive. False positive, these are the instances that were incorrectly classified as positive. Like means that is not positive, but we characterize it as a positive, so it is false positive. And like true negative, that are instances that are were correctly classified as negative. So means it was negative and it classified as negative, so it's true negative. Good. And like false negative, these instances that were incorrectly classified negative. So like the things that are positive but classified negative, so this is false negative. So the accuracy of a model is calculated by dividing the number of correct classification TP, true positive plus true negative, by the total number of instances. The precision of a model is calculated by dividing the number of true positives by the number of positive classification TP, that is true positive plus false positive. So the recall of a model is calculated by dividing the number of true positives TP by the number of actual positive TP, true positive plus FN, false negative. So the confusion matrix can be used to identify areas where a model is performing poorly.